Okay, we're going to look at integrating to find other quantities. So we've already established that my position, my velocity, and acceleration are linked in the following manner. Velocity is the rate of change of my position, and acceleration is the rate of change of my velocity. So what we can say in mathematical terms is we can differentiate my position to find velocity, and we can differentiate velocity to find acceleration. We can also go the other way. So the opposite function to differentiation is integration. So if I have acceleration, I can integrate to find velocity. If I have velocity, I can integrate to find my position. When we have vectors expressed in I, j, and possibly k, we have to perform these integrations considering each axes separately. So let's have a practice of this. So I have my velocity. I'm going to rewrite this as a column vector because I just think that's nice and neat. So 8t I and 6t squared j. Now what I'm going to do is I'm going to perform an integral on both the i's and the j's there. So I'm going to add 1 to that t power. So that becomes t to the 1, t to the 2. 8 divided by 2 is 4. And then we have this constant of integration plus c. So there could be any constant here that I don't know. I'm going to do the same thing on the bottom here. So t squared becomes t cubed. 6 divided by 3 is 2 plus d, some different constant of integration. So this is now my position vector r. This is r. So that first one's done. Given that r equals minus 1i plus 2j when t equals 0, find the particular position vector. What this means is solve for that c and d. So what I can say is my r at a time of, let's be specific here. So at a time of t equals 0 equals, what does it equal here? Minus 1 and 2. So I can set that equal to this one here. So I can say 4 times 0 squared plus c, that's a 2. 2 times 0 cubed plus d. So I can say minus 1, 2 equals c and d. So I have c and I have d. Auto draw's not paying attention there. So I can rewrite r in the following manner. I can say r equals 4t squared plus c here is this minus 1. So that's actually going to be, just put minus 1 here. And then I have 2t cubed plus d. d here is 2 plus 2. So this is my particular position vector right here. Find the position where t equals 2. Well, that's just a case of substituting in into r, t equals 2. We're going to use the complete equation here, not the partial one with some unknowns. So I'm going to say that's 4 times 2 squared minus 1. And this is 4, how many times have I done that one? 2 times 2 cubed plus 2. So that'll be the position. So 2 times 2 is 4. So 4 times 4 is 16. Minus 1 is 15. And then we have 2 times 2 times 2 in that bracket there, which is 8 times 2, which is 16 plus 2 is 16, 17, 18. So this is my position at time equals 2. Let's try this one. So we have velocity. When t equals 0, the position vector is 2i minus 3j. Find the position vector r in terms of t. Find the position when t equals 2. Find the distance of the particle from the origin when t equals 2. So we'll just maybe try the first two parts of this question. So I have my velocity here, which is going to be, I'm going to write this in a column form. I just think it's easier. So 3ti half t squared j. So let's integrate both top and bottom here, which will give us my r. So I'm integrating with respect to time, and that's going to give me r equals. So add 1 to that power of t there, t squared. So that's going to be 3 over 2t squared plus c. I'm going to add 1 to that power of t at the bottom. That becomes 3. So it's going to be 2 times 3 is going to be 1/6 t cubed plus d. Now we can use this condition here to find my t and my c. So r, evaluated at the time t equals 0, is the vector 2i minus 3j. So we can substitute that t as 0 in. So 3 over 2 times 0 squared plus c. 1/6 times 0 cubed plus d. So I have 2 minus 3 equals c and d. So I have C and I have D, which means I can write my R. So these two are kind of coming together here. My R is 3/2 t squared plus 2 and 1/6 t cubed minus 3. Okay, so the position when t equals 2, I'm going to substitute in t equals 2 here. So at t equals 2, so my position at t equals 2 is going to be 3/2 times 2 cubed. Well, really that bracket should be like that. Plus 2, and then 1/6 times, oh, that's a squared, excuse me. That's a square. And that should be 1/6 times 2 cubed minus 3. So let's find that position. So R is going to be 3 times 2 is 6, plus 2 is 8. And then I have 2 cubed is 8. 8 divided by 6 minus 3. 8 divided by 6 minus 3. So I've got 4/3 minus 3. I think that's a calculator job. 4/3 minus 3. 4/3 minus 3 is minus 5/3. Minus 5/3. Not a nice number. Okay, so hopefully that helps.